So we have a quiz tomorrow on Pythagorean theorem and reducing radicals. So let's do this. We should have a cleared out calculator. Cool. So, first things first, let's remember what Pythagorean theorem is. A squared plus b squared equals c squared. A and b are the legs, right? A, b, c. So it's 4 squared plus 9 squared equals x squared. What is 4 squared plus 9 squared? 97 equals x squared. And to get rid of squared, we do square root. Alright, now it's 97 prime. So, nothing goes into 97. So yeah, it's just the square root of 97. Okay, number 2. So, we got A, B, C. So once again, Pythagorean theorem. Notice we're missing a leg. So we're still going to do a squared plus b squared. Notice b is x and equals c squared across from 90, 14 squared. So we know 2 squared is 4. Sorry, 14 squared is what? 196. Okay, now before I can get the square root, I need to get rid of this loner 4. So minus 4, minus 4. X squared equals 192. And I need to find the square root, 192. Okay, so what's the square root of 192? Well, it's even, so 2 times 96. Alright, and then that's even, so 2 times 48. 2 times 24. 2 times 12. 2 times 6. 2 times 3. That is a lot of 2's. How many pairs do we got? 1 pair? 2 pairs? 3 pairs. 2 times 2 times 2 times 3. I mean, sorry. 2 times 2 times 2, those 3 pairs go out. The loner 3 stays in. So, this should be not square root. I have a square root sign, but outside will be 2 times 2 times 2, which is not 6. 2 times 2 is 4, 4 times 2 is 8. Okay, the loner 3 stays inside. Cool. Okay, same idea here. It's even. 2 times 630. Okay, that's even. 2 times 315. Not even, so 3 times 105. Try 3 again. 3 times 35. And then 3 doesn't work this time, so try 5. 5 times 7. Cool. So, pair of 2, pair of 3, loner 5, loner 7. So, 2 times 3 on the outside is 6. 5 times 7 on the inside is 35. So, on number 4, outside times outside is outside, 10. 5 times 2 is 10. Square root, inside times inside, 10 times 3 is 21. Cool. On number 5, you can only combine like terms. Combine like terms. terms. So my like terms are 1 square root of 3 minus 3 square root of 3. Those have the same square roots. So 1 minus 3 is negative 2 square root of 3. And then my different square root is going to come down next to it, plus 5 square root of 2. You cannot combine different square roots. Okay? Number 6, pool floating measures 8 feet long. Cool. It has a diagonal measure of 9.2. Diagonal means from here to here. 9.2 feet. Okay, find the width of the pool. So we'll call this X. It is a right triangle. So we'll call it A, B, C. So again, Pythagorean theorem. A squared plus B squared equals C squared. And we should be able to find the width. So let's do this. Now, in this case, we're going to have to find the decimal. So 8 squared is 64. 9.2 squared. 84.64. And then we need to get rid of that 64 on the left, so subtract it. X squared equals 20.64. And then to get rid of the square, square root. Now, we're going to find the decimal answer, so the square root, 20.64. Because we can't factor tree a decimal, so that's 4.54. And our units are feet. Last one, a baseball diamond is square with sides of 80 feet. All the way around, 80, 80, 80. Alright? Label what you know. What is the shortest distance from the nearest tenth of a foot between first and third base? So here's first, here's third. And since this is a square, we have a right angle. So once again, right triangle on the bottom. We're missing X. And if we label A, B, and C, C is across from the 90, we have another Pythagorean theorem problem. And since we're doing to the nearest tenth, that is a decimal as well. Cool. So let's set it up. A squared plus B squared equals C squared. Now what is 80 squared? 6,400. By the way, these are all feet. Okay, add those up. 6,400 plus 6,400 is 12,800. And again, since it says nearest tenth, let's square root that. 12800. 113.1. It does say to the nearest tenth. That's in feet.